Okay, so today we are looking at Module 11, Lesson 2, and you'll see that I have my paper here to do the problems on, as well as the Module 11, or Week 2 is what I call it, Lesson 2 printout. So that's what I'm going to be working on. In this first lesson, what we're doing is we're looking at where lines intersect. And when they intersect, there is going to be one single solution that when I plug that point in, it would work for both of the equations. Let me zoom in just a little bit here. Let me go to 150 so that we can see this a little bit better. So for example, in this right here, this graph, we're looking and we're seeing that there's only one point that would be true when I plug it in for both this line and for this line. They only intersect at one place. And that place is at -3 on the y-axis and 1 on the x-axis. So my point that would be a solution would be 1, -3. Okay, but I want to double check this. And part of your homework is going to be to identify the lines, like what's the equation of the line for each one of these. And then what we do to check it is we plug this point in to make sure that it's going to be true. So I kind of want to take you through that entire process. We'll do the first two actually. So for this first one, in order to find the equation of the line, actually, this one I'm not going to do because oh man, do we have any good graphs here? Yeah, we can do the last one. This one, in order to go any further on this one, I would need to know exactly what the y-intercepts are, and I don't have any point for that. Also, I can tell that the slope is not a pleasant slope for this one. So I'm actually not going to use this one to do that. We'll just do that to show that this is a solution to those two. When I plug that point in, it would actually work in both equations. I'll show that to you on the third graph. On this one right here, it looks like the point that would be a solution for both of them. So the second graph, the solution point would be at, on my x-axis, 1, 2. Okay, on my x-axis, it'd be 2. And on my y-axis, it would be -1. That would be the point of solution for that system of equations. That's a fancy word for two equations where they intersect. Again, you can see the y-intercept on this is not going to be a nice one. But my third graph is, so I'm going to look at that one. Okay, so we'll do all the things with this third graph. So the first thing that I notice is that my solution point, it looks like, is at -1, 1, 2, 3. -1, 3. -1 on my x-axis, 3 on my y-axis. So that is the point that I think is a solution to both of these. Well, let's find the equations of the lines first. So the first thing I'm going to do is I'm going to look at my red line. My red line has a y-intercept right there, which is at +2. But more importantly, before I do that, I need to figure out what my slope is. Well, from this point to that point, to that point, to that point, what I'm doing is I'm going down 1 over 1, down 1 over 1, down 1 over 1. So my slope, I'm going to have y equals mx plus b. So mx plus b. Okay. My slope is -1. So I'm going to have -1x, or you could just put -x, but -1x, and then my y-intercept. So my plus b, my y-intercept is at 1, 2. So I'm going to put +2. Okay. The equation of the blue line. The equation of the blue line, it looks like my y-intercept is at 1, 2, 3, 4, 5, right? But I need to figure out what my slope is. Well, from that point to that point to that point, what I'm doing is I'm going up 2 over 1, up 2 over 1. So I get y is equal to 2 over 1, which is just 2x, okay? Then plus 1, 2, 3, 4, 5, plus 5, because that's my y-intercept. Well, now I want to make sure that this is truly a solution. To check to see that it's truly a solution, when I plug it into this line and into this line, when I plug it in, it better work. If it doesn't, then that's not a solution. It's not where they intersect, but we're going to plug it in. So in my first one, I have my y is, so 3 is equal to -1 times my x, which is -1, plus 2. All I did was plug in for x, -1, for y3. I'm going to do the same thing for the other one. So I need to plug this point into this one as well. So I'm going to have 3 is equal to 2 times -1 plus 5. Now I just need to make sure that these are true statements. So in this one, I have 3 is equal to -1 times -1 is +1, 1 plus 2. Yep. 3 is equal to 1 plus 2, which is 3. Okay, so on this side, I'll clean it up. 3 is equal to 2 times -1 is -2 plus 5. -2 plus 5 is equal to 3. So I checked it and it actually works in both of them. So that is the correct answer. Okay. The last thing we're going to do today is actually kind of for tomorrow's lesson, but I do want to do one of these so that you can see it today. And then we'll be looking more at it again tomorrow. But it says the Alpine Music Club is going on its annual trip. The members of the club are yodelers and they like to play the xylophone. This year they are taking their xylophones on a gondola to give a performance at the top of Mount Munch. The gondola conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club, including the xylophones, to ride the gondola. 2 yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. How many yodelers and how many xylophones are on the gondola? So the gondola conductor charges $2 for each yodeler. Well, first of all, I'm going to have my y. So I'm doing a separate problem. I'm going to start defining my variables first. My y, that's going to be the yodeler. Okay. And then the x is going to be my xylophone. I like to make my variables instead of having, well, I guess these are X and Y, but instead of having just like X and Y, I'll make like for hot dogs, which is one of your problems tonight, I'll do H and corn dogs or C's just to make it easier. So the gondola conductor charges $2 for each yodeler. So now I'm going to do the money part of it. So this is kind of like the money part. So for the money part, we have $2 for each yodeler, plus $1 for each xylophone equals a grand total of $40. Okay, but 2 yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. So my second equation that I'm setting up here is actually having to do with that. I have twice as many gondolas as xylophones. So what I have is my yodelers, okay, my yodelers is equal to twice as many as the number of xylophones. My yodelers is 2 times X, okay? Okay. So now the way that we're going to go through and solve these, this is kind of the first part, is getting the equation. That's the hard part. The easier part is to actually go through and solve this equation. And what I'm going to do is, since I have y equals something already, I'm going to use a method called substitution. I'm going to take wherever there's a y, because y is equal to 2x, wherever there's a y in this equation, okay, which is only one time, I'm going to plug in 2x instead. What this does is it makes, because right now this is 2 variables, it's going to make it so that this is only 1 variable, so I can go through and solve. This is called substitution. So what I have now is 2 times, and instead of having a y, since y is equal to 2x, I'm going to plug in 2x plus x is equal to 40. So here I have 4x plus x is equal to 40. That's 5x is equal to 40. Okay, which means x is equal to 8. So I should have 8 xylophones. Well, now I need to know how many yodelers there are. All you do is plug in 8 to one of your equations. You could plug it in there, you could plug it in here. I'm going to plug it into this one because it just seems easier. So what I'll have is y is equal to 2 times 8. So I should have 16 yodelers. which makes sense because there are twice as many yodelers as there are xylophones. Now, I always double check myself to make sure that I did it right, which is exactly what we did up here. I'm going to go through and I'm going to plug in 8 and 16 into this equation right here to make sure that it works. Because I already kind of did it in this equation, so I'm going to do it in this one now to make sure that that would give me the $40. So I'm going to have 2 times my yodelers, 2 times 16, plus 1 times my 8. That should be equal to 40. Okay, so I'm just plugging in for X and Y in this equation. Well, 2 times 16 is 32 plus 8. Does that give us 40? 32 plus 8? Yep, it does. So I know that I've done it correct. This is the right answer for me. Okay. So that's all we're going to do today. These are kind of like the 2 parts of what you're going to do. The first part, you're going to be looking at graphs and then going through to see if that point is a solution, verifying it. And the second part is going to be taking the equations and using substitution in order to solve.